topography. But in a cataract clinic, you may not use a topography, you just have a keratometer, but it's very important to invest in a topographer today because you're using premium lenses, and let's see the impact on cataract surgery. So with the increased use of premium IOLs, so it's very important to do a careful pre-op assessment to see if the patient is suitable for the premium IOL or not. So currently, like I said, topographies are not considered as part of the routine pre-op workup for cataract patients. However, a number of corneal pathologies can be identified with keratometry. They cannot be identified by just a keratometry, biometry, or slit lamp, which are considered the standard test. So you need topography. And I'll give you 10 reasons why you need to invest in a topographer if you're doing cataract surgery and premium cataract surgery. So the first is to assess the ocular surface. You can assess the ocular surface with a topographer also, because again, there's another paper, effect of tear osmolarity on repeatability of keratometry, and you can have a lot of variation if you have ocular surface disorders. So dry eye, meibomian gland dysfunction, poor ocular surface, contact lens warpage. So these are things that are important and have to be assessed. Contact lens warpage assessment needs topography. So if you have a Placido-based topographer, the axial curvature maps can give you an idea about the careful. If you just look at the Placido rings, and if you see they are distorted, it may be that the patient has a dry eye. So just looking at the rings before actually acquiring the topography, you can actually know that the patient has dry eye or not. The op scan, atlas, OPD scan, you can have that. And sometimes the dry eye mimics irregular astigmatism. And you may think that this patient is not suitable for a premium lens because he has irregular astigmatism, but when you treat the dry eye, then it improves. So this is a patient who had pre-treatment. You can see that the astigmatism is irregular. You see this area of flattening. Even the K readings are totally different. Post-treatment, you can see the ocular surface is much better. It becomes more regular, and you can use a toric IOL for this case. So a topographer is very important to also determine this. And elevation-based topographers like the pentacam can differentiate between corneal contact lens warpage and keratectasia. So you can see here that the difference map shows changes in the sagittal curvature map, but there is no change in the posterior elevation. You can see the posterior elevation is the same, but the sagittal, if you look at the difference map, you can see that there is quite a difference here. And this is because of contact lens warpage. Second is you can identify abnormal corneal shapes like palm fruste keratoconus, pellucid marginal disorder, and LASIK ectasia. So you can see here, this is keratoconus with a central cone. If you have a central cone, then and astigmatism, you can use a toric lens. But if you have a decentered cone like this, then you will not get a good result with a toric lens. So the patient has astigmatism with a decentered cone. So this is how you can differentiate. And this is a PMD, pellucid marginal degeneration. And also it's helpful in assessing corneal irregularities because of scars, pterygium, nodular degeneration, or epithelial basement membrane disease. Third is it gives you the corneal higher order aberrations. So you have to look at the RMS, which gives you the total of the root mean square of the higher order aberrations. Less than 0.3 is ideal. Less than 0.5 is acceptable. So you can use a premium IOL if it's less than 0.5 microns RMS, but if it's more than 0.5, then it's a contraindication to use multifocals. So in this case, you can see this is the Zernike polynomials, which are analysis which is given by the pentacam, and here you can see that it is 0.339. So this is kind of normal, so this patient can be taken up for a multifocal IOL. Fourth point is it gives you the cornea spherical aberration. So spherical aberration is very important because today you have lenses with different asphericities. So the aspheric lenses enhance contrast sensitivity by either negating the cornea's positive spherical aberration. The cornea has positive spherical aberration. So if you use a lens with a negative spherical aberration, then it improves the whole visual system because the total spherical aberration comes to almost zero, like the Technis or the Alcon-Acris of IQ. And you have some lenses which do not affect the spherical aberration, like the soft port Leo. So depending upon the measurement of the spherical aberration, you can decide on what type of lens you have to use. So I'll show you some examples. If a patient's corneal spherical aberration is known, you can tailor an aspheric lens using corneal topography to decide on what type of IOL you want to use, either a spherical, aspheric, or a zero or a spherical aberration, that is an aberration-free lens. So this is a normal cornea, and you can see that the normal cornea has a positive spherical aberration. Here the Z4. Z4 is spherical aberration. Z4 is 0.283, so plus. So this is a normal positive spherical aberration, normal cornea. So you can use an aspheric IOL with negative asphericity like the Technis or the Acris of IQ. And this will give the patient very good quality of vision and high contrast. This is a post-myopic refractive surgery. It has a higher, they have a higher plus positive spherical aberration. You can see the Z4 is 0.677. You can see the central flattening induced by the ablation there. And in this case, you can use an aspheric IOL, which has negative asphericity, again like the Technis or the Acris of IQ. This is a post-hyperopic LASIK. You can see that the central steepening there. Or if you look at a case of axial keratoconus, again you have central steepening. So these are cases where you would want to use a spherical IOL, that is a lens which has a positive spherical aberration because these corneas have a negative spherical aberration. So to counteract the negative spherical aberration of the cornea, you have to use a lens with a positive spherical aberration, like the Sensor. And then you have some eyes with very high corneal aberrations. Example, post-LASIK ectasia or advanced keratoconus, marginal degeneration, post-RK. These are patients where you would like to use a aberration-free IOL. Fifth reason why you need a topographer is to differentiate the type of laser ablation in post-refractive surgery cases. This is a post-myopic LASIK, you can see the central flattening, and post-hyperopic, you can see the central steepening. And also, if you have a pentacam post-refractive surgery, you get the holiday EKR report, which is very useful to know the distribution of the K value. So if you have a nice Gaussian spike here, then you know that the cornea is fairly regular and the distribution of the Ks are regular. You don't have any decentration of the ablation. This is a post-myopic LASIK, but you can see the distribution is quite good. It's almost normal. So these patients, you can use a premium lenses like multifocal lens. Post-hyperopic LASIK, again, you can see the distribution is a little off. And you can see there's a mild decentration there. So these are cases where you'll be careful and you'll counsel the patient that the recovery post-op is not going to be that good. You will avoid using a multifocal lens. This is again a post-RK. You can see the extreme flattening here, and you can see that it's very irregular, the distribution of the Ks. And these are patients where you want to avoid using a premium lens. You're going to counsel the patient that the refractive results post-op is not going to be very good. You may have to wear glasses, or the quality of vision is not going to be good. It also gives you the ZDK analysis where you can look at the different aberrations. Topography, the sixth reason is topography will help you customize your manual LRI or arcade incisions with a femto for astigmatic correction. You know what is the steep axis and the flat axis, so you can plan your astigmatic incisions. It also gives you regional pachymetry, so you want to set the depth either with your laser or with your blade, then you have the exact measurements, so you get the adequate effect. Seventh, topography will also help you know the suitability for a toric IOL. So Schleifer based tomographers provide both anterior and posterior astigmatism values, which helps make a decision whether a toric IOL is required or not. It also tells you whether the astigmatism is orthogonal, non-orthogonal, or irregular. So if the astigmatism is irregular, then you want to avoid using a toric IOL. So you can see here that I don't think it's very clear, but this is the SIN case, but you want to look at the total case. The SIN K here shows 1 diopter, but the total K is 0.7 because the posterior cornea actually takes away from the anterior cornea. That's why the total corneal astigmatism is different from the anterior corneal astigmatism. Generally, the total astigmatism is more than 1 diopter, then a toric lens implantation is required. Eighth is verification of the axis of astigmatism. Sometimes you have the repeatability is not very good, so you want to know what is the axis of the astigmatism. Your manual keratometer, optical biometer, or autorefractometer may show different values. So then that's when you turn to your topographer. The SIM case or simulated keratometry provided by topography is not very accurate for IOL planning, so don't take the SIM case. However, the topography can be very helpful for determining the true axis of astigmatism. So if you want to know the axis, then finally you can use your topography. If there's a confusion or you have varying values, there was an article in the iWorld about this. Ninth, it is useful, the topography is useful for IOL power calculation in post-refractive surgery eyes because you have topography-based formula which is available on the ASCRS online calculator. So you have different topographers, you have the ISIS, the TOMI, the Galilei, Pentacam, Atlas. So whichever topographer you have, you can put in the values. You can also use the Pentacam TrueNet power and put in the Pentacam TrueNet power for the calculation. And if you have the Atlas, you can use the Atlas ring and zone values. So, and of course, the 4 mm EKR values with the Holiday EKR report, you can use it with the Holiday 2 formula for post-refractive surgery cases, and this is quite accurate. We were using this previously before using the Barrett TrueK. The Barrett TrueK is what we use now. We have the TK TrueK, which is just coming out, which is the most accurate, but I think that will be dealt with by another speaker. Then the last point is an objective grading of cataract. If you have a Pentacam, you can do what is known as the PNS or the Pentacam nucleus staging, grade the cataract from 0 to 5, and this number provides a comparison between your log scoring which you do on your slit lamp and the PNS grading of the nucleus, and then you can use this to mark this on the chart, use it in the OR for your phaco parameters, etc. Nowadays, insurance companies also are asking for evidence of cataract because sometimes refractive lens exchange is being done and then passed off as cataract surgery for reimbursement. So you may have to provide them an objective grading of cataract and the images. So it may be useful in the future. So this is, you can see the full spectrum of PNS grading from 0 to 5. Soft nucleus 0 to 1, medium 2 to 3, and hard 4 to 5. So you can see that how the density varies. You can also custom match it and then for your phaco settings. This may be the future. So to conclude, corneal topography is an indispensable tool for a premium IOL cataract surgeon to assess the ocular surface, corneal shape, and aberrations that allow for proper patient and IOL selection. And incorporating corneal topography in a premium IOL practice certainly will improve your clinical outcomes and enhance patient satisfaction. Thank you very much for your attention and questions.